This is part one of a two-part program designed to provide instruction on how to use AirTest CO2 Demand Control Ventilation Energy Analysis program. Hi, I'm Mike Schell and I'm with AirTest, and I'll be guiding you through this tutorial today about how to use AirTest CO2 Energy Analysis program. As you can see, there are four major topic areas we're going to cover today. First, we're going to talk about who AirTest is. Second, we'll talk about how the Demand Control Ventilation Analysis program works. Then we'll actually walk through the process of entering data into the program. And finally, I'll show you how to review the results and actually how to customize your own program. Well, let's get started. First of all, just about AirTest, we make a wide variety of sensors for buildings. In particular, since we're talking about CO2 today, I'd highlight that AirTest offers two different types of CO2 sensors. One under the AirTest brand, which is available in a wide variety of configurations, that has a very long life of 15 to 20 years, is self-calibrating, and is available in standard analog versions, LawnWorks, and soon to come BACnet. We also have another device from an Austrian company we've been working with for a number of years called E+E Electronique. These particular products actually incorporate CO2 measurement, temperature measurement, and even humidity measurement on board. They also have their own unique method of self-calibration that assures a long, maintenance-free life. So, the AirTest Demand Control Ventilation Energy Analysis is a program that's based on an Excel platform. If you have a PC, Excel 2003 probably works. For Mac, you'll need the 2010 version, the latest version of Excel. You'll find as we move on that there are different programs for different regions. The files are actually 25 megabytes in size, and the reason for that is the climatic data we use. There's a lot of data that we're referencing when we're doing this calculation. Now, it's important to remember that this isn't like a lot of energy analysis programs that look at the entire building and how much energy is used. Rather, we're just looking at outside weather data and the cost and energy required to heat and cool that air to the kind of conditions that you'd want inside the space. I also warn you that when you do this, the results are highly dependent on what you input into the program, and there are a lot of inputs that are possible. So just be careful when you're using the program. What we use for this information is hourly temperature and dew point data for outside air that is typically used in this kind of calculations. The source for the data is actually from ASHRAE, and it's called TM2Y data. Now, when we talk about building outdoor air or the phases of how a building operates, there's this pie chart sort of shows how it operates according to the way we look at it with this program. There's a cooling, heating, an economizer mode where you can actually use outside air for free cooling if it's appropriate. And then there's a neutral point where maybe for some period of the year the building needs no heating or cooling. It's in balance. But when we take a look at this from an energy analysis perspective, we know that CO2 demand control ventilation occurs when the phases that you see are in operation. However, when the economizer is operating, we really turn off the CO2 sensor or ignore it and just bring in 100% outside air because it's actually helping us provide free cooling. So this energy analysis we're going to go through considers both the CO2 part of the energy savings and the economizer part of the energy savings. Now, there are four different economizer operations in this analysis. Number one is no economizer because there are plenty of hot and humid climates where you just can't use an economizer because the outside air never gets cool enough. There's temperature-controlled economizers that are fairly common, enthalpy-controlled economizers, which are less common and considered somewhat troublesome. And then what we've started to advocate is measurement of dew point and temperature economizers, where dew point is a measure of the actual amount of moisture in the air, and the temperature economizer obviously measures the sensible energy in air. Now, the reason we're advocating this is in a recent ASHRAE humidity design guide, what they found was traditional enthalpy or temperature controlled economizers can introduce excessive moisture into buildings because they're not actually measuring the moisture. Enthalpy measures a hybrid of moisture and temperature, total energy, but doesn't measure moisture separately, and temperature just ignores moisture completely. This can happen for thousands of hours each year during the evening, night, and mornings when outside temperature is low but moisture remains high. So the answer as we see it is to set the economizer so it never uses outdoor air with a higher dew point than what you have targeted in the building. So for example, if you have a target of 50% RH and 74 degrees F that you don't want to exceed, if you go into a psychometric chart, do the calculation, that's a 54 degree F dew point. And that dew point, regardless of the temperature, will stay the same. So it's an anchor point that you can better control an economizer on. And this is one of the options that's offered in the program. Also, one other thing is that this is an article written by Steve Taylor in the December 2010 edition of the ASHRAE Journal. And he wrote a very informative article on why enthalpy economizers don't work. And the main reason for this is that because the humidity sensors that are used in these inexpensive enthalpy sensors don't work. And this is a study done by the Iowa Energy Center where this is a plus or 3% accuracy, and accuracy is down here, and the actual relative humidity is here, and you can see how much of the reading, now mind you this is the worst sensor they came across, but how much of this sensor data is outside of these two error bars here. And basically what they found is many sensors out of the box just don't work. In fact, if you go today to the most popular enthalpy sensors that are used for controlling HVAC equipment and take a look at the data sheet and look for something that says anything about accuracy, you'll see that accuracy is not stated. So one thing that this energy analysis program will do will estimate energy savings from an enthalpy economizer, but you've got to understand that that's if one has an accurate sensor and an enthalpy sensor that actually works. And our experience in the real world today is that it really doesn't. For better economizer control, what we then recommend is control to temperature and dew point. And rather than using a single inexpensive unit in each device, we recommend using a centralized outside air weather station quality sensor to control all the rooftops or equipment on a building. In fact, we work with the city of Pasadena who control all their buildings within about a 2-block radius with one of these devices. It provides a much higher accuracy measurement, and that was one of the biggest criticisms of the enthalpy sensor article I mentioned before. It's virtually maintenance-free. We have data on these sensors operating 10 or more years in outside environments. It provides a direct dew point and temperature output. And another key factor when you're measuring outside air conditions is it has the proper shielding against wind, rain, sun, and snow, which can cause significant errors in measurement. So that's the background to the program. Now, to talk about the information that's needed, we need the design occupancy of the space, the design ventilation rate of the space, operating hours, an idea of how the occupancy actually varies on an hourly basis, the cost of energy, and basically what the 100% airflow capacity of the air handling system is. And this is used for the economizer analysis. You don't have to worry about this if you don't have the economizer function as part of your concern. So, to get started, if you want to get the program, you can download this PDF document, which I'll just let you take a look at there. And when you download that document, it will look, just give me a moment here, it will look like this. And basically it's a map of the United States and Canada and lists all the different cities that are in each of the databases. So each one of these groupings represents one program with these particular cities in. Basically pick the program that you're looking for. In this case, in our example, we're going to go to the central US, and basically it will download it from our website. A copy of this video can also be downloaded by clicking here so you can see it. So that's basic explanation and background on the program. Now we're going to get into actually discussing the program itself. All right, so here we are now. We've got the program downloaded onto our computer, and I said we were going to take a look at the Central USA program. So basically, I double-click on the program to open it up. And one key thing here, if you're using a PC, you may not see exactly the same thing, but the key is that you do have to enable macros for this program to work. In the Mac version, I know it asks you for that question. You may have to actually go inside the program and take a look at it otherwise. Okay, now we've got the program open. And I'll just move it into the screen here so you can see it. Basically, the program is set up in a way that there are, and you can see at the bottom of the screen now here, that there are different tabs, and they basically represent the steps that you go through when doing this program. So this very first page of the program actually talks about the energy analysis. Much of what I discussed in the introduction part of this is covered in here. A thing to note too is that in this program there are a lot of inputs. The ones that are in blue are really inputs that are information that's very specific to a project, so that that's the information that you have to input. Things in light blue boxes you can change, but really they could be considered default values. If you know what you're doing, please feel free to change them, but be careful otherwise. One other thing to note is some more of the background on economizers and things like that is actually located at the bottom of this about this program, where there's actually 3 articles that we've written that talk about measuring moisture, about economizer control, and the use of CO2 sensors. And also I have a link to that ASHRAE article on why enthalpy sensors don't work. So you can just click on any of those links and it will download a copy for you. The first step in this program then is really to input project information, which is really just whatever information you want to put in about the project. Please note that the building or the project name is actually something that's carried on every page, so if you fill out nothing else, you probably want to fill out that field. So then the next step is we basically go in and establish the ventilation conditions. First, we input the design occupancy, which is really the occupancy that the building engineer or mechanical engineer that the building was designed for. In this case, we're talking about kind of a retail drugstore type application like a CVS. Actually, floor area typically is 12,000 square feet. You can see it calculates the design density. Again, all we want to input is information into the colored boxes. The design ventilation rate is 15 CFM, fairly standard. And one of the things we want to make sure is if the space has low occupancy, we don't want to shut the outside air completely off, because there's other things not related to people being there that are always off gassing that require some level of ventilation. In this case, I've put 20% of the design ventilation rate of 3,900 as being during occupied hours. That outside air will always be coming in. As a result, in our energy analysis, we have to always account for heating and cooling that portion of outside air. Finally, for the economizer estimation of it, we have to determine what the total CFM of the system is when it's completely open. And typically, if you don't know, as a rule of thumb, you can take 4 or 5 times the design ventilation rate and have that be your economizer rate. But it's much better to take a look at the information about your equipment in a mechanical schedule, or even doing an airflow measurement when the system is 100% open and determining what that level is. Okay, so then we have the building characteristics set up. The next step is to really set the parameters for heating and cooling. Please go to part 2 of this video to see the rest of the tutorial.